बताया है, थ्योरम हैज नॉट सेड दैट वी कैन टेक द रिवर्स। अगर हाँ यहाँ पे कोई -1 नहीं होता तो इफेक्ट नहीं पड़ता, क्योंकि यहाँ पे माइनस, क्योंकि अगर कोई छोटा नंबर को हम -1 कर रहे हैं तो सोल्यूशन में, अगर फिर हम छोटे को बड़े से डिवीजन करेंगे या बड़े को छोटे से डिवीजन तो उसमें सोल्यूशन में इफेक्ट पड़ जाएगा, इसलिए -1 जब आएगा तो सोल्यूशन में इफेक्ट पड़ जाएगा। सो दिस इज रॉन्ग, क्योंकि थ्योरी इज नॉट सेइंग, अगर थ्योरी में होता तो हम लोग के पढ़ाते हैं, थ्योरी सेज दिस। Okay, now let us come to the eigenvalue.
Ma'am, has any date been decided for the quiz?
No, not yet decided. You don't have a WhatsApp group, comment group, like last time there was a group with the coordinator. With other batches, you don't have a group?
No, ma'am.
Okay, you can mail, if you are interested, then you can inquire through the coordinator. Or you can wait. Okay, because we too don't have the information. Maybe some other batches have not finished it. That is why we don't have the information. Okay, now let us come to the eigenvalues. So if we have any matrix A, the matrix has to be a square matrix, क्योंकि हम लोग को determinant निकालना है, ठीक है? Whenever we need to find the determinant, the matrix has to be a square matrix. So if any square matrix is given and you have the determinant of the matrix, like A is the matrix, so if we find the determinant of, okay, A minus lambda I is equal to 0. So this I is called the identity matrix. This is called the I. So identity matrix will obviously be same as the order of the matrix. Okay, otherwise you cannot do the subtraction. So if you take the determinant of A minus lambda I is equal to 0, then you will get some polynomial form. जैसे अगर यहाँ पे हम छोटा सा matrix ले रहे हैं, suppose A1 minus lambda, suppose there is some value, suppose यहाँ पे कुछ एक simple सा ले लें 0 ताकि calculation आसान हो, 0 and A2 minus lambda. If you take the determinant of this, so you will get a polynomial equation. Determinant of this is equal to 0. You will have A1 minus lambda into A2 minus lambda is equal to 0. So this will obviously give a polynomial like A square minus lambda into A1 plus A2 plus lambda 1, lambda 2. अच्छा यहाँ पे lambda 1 ही ले ले, so that we can understand what are the eigenvalues. अच्छा यहाँ पे आ जाएगा, then there will be a change. अच्छा lambda लेते हैं तो पूरा calculation, it will not affect whether you take a lambda 1 or lambda 2. So this is lambda square, that will not affect. You will have A1 A2. Okay, so when you write it reverse, so this is actually a polynomial of degree 2. So if you have an n by n matrix, it is obvious that you will get a polynomial of degree n. Now when you, this is an equation now. Okay, so when you solve this equation, you will get the root, the solution of this equation in terms of lambda. Those solutions will be called the eigenvalues of which matrix? Of this matrix. So this matrix will be called as characteristic equation. Characteristic equation. So to get the eigenvalues, of matrix A, to get the eigenvalue of this matrix A, we construct the characteristic equation which is given in the form of determinant of A minus lambda I is equal to 0. So when you are constructing characteristic equation, this becomes an equation of degree which is same as the order of the polynomial. अगर polynomial which is same as the order of the matrix. अगर matrix का order 3 है, you will get a polynomial of degree 3, and the degree of the polynomial will give the number of roots of the equation. ये पता है ना, जितना degree होगा उतना ही roots निकलेगा. So if the degree of the polynomial is 3, you will get 3 roots. So if this matrix is of order n, and you construct the characteristic equation, you will get an equation which will be of degree n. So the roots of the, if you solve that equation, then you will get the roots. Those roots you will get n roots. They may be either repeated roots also, or you can have all different roots also. And those roots will be called as eigenvalues of the given matrix. Clear?
Ma'am, can you
So in
part after making the characteristic equation, like what we do? First we make the
yeah.
characteristic equation.
So if you are having, you have given any matrix of order, suppose n, and you are asked to find the eigenvalues of the matrix. So what we do, we construct the characteristic equation. The characteristic equation is given as determinant of A minus lambda I is equal to 0, where I is the identity matrix which has to be same as order of the matrix. ये तो obvious होना है क्योंकि matrix subtraction तभी possible होगा जब दोनों matrix का order same होगा, है ना? वरना subtraction नहीं होगा क्योंकि ये operation आ जा रहा है minus. तो ये एक मैट्रिक्स है, दिस इज अ मैट्रिक्स एंड दिस इज अ स्केलर. जैसे इफ यू हैव अ मैट्रिक्स 1 2 3 4 एंड लैम्डा इज अ स्केलर एंड दिस इज अ मैट्रिक्स 1 0 0 1, तो ये स्केलर इसके साथ मल्टीप्लाई हो गया तो यहाँ पे लैम्डा आ जाएगा, इट विल गो इनसाइड. नाउ दिस विल बी subtraction is possible when the order of both are same, so यहाँ पे that has to be the same. So this determinant of A minus lambda, when you break up, you will get a polynomial of degree which is same as the order of the matrix. If the order of the matrix is n, you will get a polynomial of degree n. अब हमें ये theory पता है कि अगर if there is any polynomial of degree n, then the number of roots will also be the be n roots. जितना degree होगा उतना ही roots निकलेगा.
Yes.
तो if you solve this, now this becomes an equation क्योंकि equal to sign है. अगर equal to sign नहीं होता तो equation नहीं होता, इसीलिए यहाँ पे equal to sign लेके कर रहे हैं so that we can find the unknown value lambda. So when you solve this equation, you will get the roots of this equation. Those roots are called the eigenvalues. Okay. So in another word, you can say the eigenvalues are the roots of the characteristic equation. Determinant of A minus lambda I is equal to 0. ये book में है ये definition. ठीक है? जो book upload है उसमें है. So that is eigenvalue. Eigenvalue is clear. Now for every eigenvalue, we can get an eigenvector. ठीक है? Eigenvector कैसे निकालना है? We have the equation like ax is equal to lambda x. Suppose this eigenvalue lambda is known to you and a is known to you. Now we have to find the eigenvector corresponding to this. So we construct an equation which is of the form ax is equal to lambda x. So this equation is obviously a homogeneous equation. Isn't it? So you can take it like this, a minus lambda I into x is equal to 0. So this gives a homogeneous equation. अब ये जो system homogeneous निकलेगा, so this you can see, you can recall. हम लोग जब वो ये निकालते थे solution of system of equations, उसमें भी इस type का आता था solution of system of equation के लिए ax, a हमारा रहता था यहाँ पे we used to take, and यहाँ पे we used to take the x k1 k2 का भी हम लोग को याद रखो, we used to do it like this is equal to 0. यहाँ पे b है, इस टाइप का इक्वेशन बनता था. So over here what we are getting the homogeneous equation. So whenever we have a homogeneous equation, the system of equation is always consistent, है ना? Consistent. So consistent का मतलब है we can have a solution. The solution can be either a zero solution या क्या होगा? Anybody?
Infinite.
हाँ, और infinite solution. ये हम थ्योरी भी दिखाए थे, मतलब बता रहे थे जब when we were solving, when I was explaining a system of equation. So there will be two possibility. अब zero solution कब होगा? When the rank is same as the rank of the matrix, यानी कि हमारा all vectors are linearly independent, तभी हमारा zero solution होगा. Infinite solution तब होगा जब हमारा dependent हो जाएगा, तभी ना हमारा rank decrease हो जाता है. जैसे कोई भी element अगर zero हो गया तो that will have the rank less than the rank of the matrix, कि कोई भी row zero होने से वो हो जाएगा. Then we have an infinite number of solution. Now we have to find for what value of lambda, we are having a non-zero solution. Okay, we have to find those values of lambda for which we get a non-zero solution. And those value x will be called the eigenvectors of the eigenvalue lambda. क्या समझ में आया?
Yes,
Yes,
ma'am.
ma'am.
So finally, what we have to do in order to get the vector, we have to consider this homogeneous equation, put the value of lambda that we have got in the above equation. Then you get the system of equations, solve the system of equation, and find the value of x. And those values of x should be a non-zero solution. ठीक है, तो यानी अगर नॉन जीरो सोल्यूशन है तो उसका मतलब क्या हो रहा है? यहाँ पे तो दो ही सोल्यूशन का पॉसिबिलिटी है, एक आइदर जीरो है और इनफाइनाइट सोल्यूशन है. जीरो सोल्यूशन को ट्रिवियल सोल्यूशन भी बोलते हैं. तो इसका क्या मतलब हो रहा है? इफ वी हैव अ नॉन जीरो सोल्यूशन फॉर द होमोजेनियस सिस्टम, अच्छा एक एग्जांपल लेते हैं तो समझ में आएगा. क्या ये थ्योरी समझ में आया ना अभी? एनी डाउट ओवर हियर? व्हाट इज आइगन वैल्यू, व्हाट इज आइगन वेक्टर? So in simple, I can say that to get the eigenvalues, you have to solve this characteristic equation, which is determinant of a minus lambda I is equal to 0. And to get the eigenvalues of lambda, we have to solve this equation ax is equal to lambda x or a minus lambda I into x is equal to 0. We have to solve this equation, find the value of x. Lambda to humko aage se mil gaya. From the previous equation, we are getting the lambda. So this matrix is known to you. A is known, lambda is known, and I is also known. So when you put this, you will get this known thing, and this is unknown. So we have to find the unknown value x. That means just we have to solve the system of equation. Let us come to the example. Let us take a simple example. Find eigenvalues. Find the eigenvalues of this. So first thing that I have said, the eigenvalues can be obtained by the characteristic equation. From this equation, now you solve this equation. You know A, you know I, so lambda you can get. So you will get a polynomial of degree 3 because this is a 3 by 3 matrix. Okay, so when you solve that polynomial equation, you will get 3 roots. Those roots are called the eigenvalues. I think you can solve. That is determinant of -2. Direct also you can do. Now first time I'm explaining is indirectly. मतलब step बता दे रहे हैं. इसको चाहो तो वैसे भी लिख सकते हो. So this is the matrix minus lambda 0 0 0 lambda 0 0 0 lambda. So this is the determinant of this is equal to 0. Now you simplify. See one thing that you note, यहाँ पे equal to मत लिखना because both equal to cannot be written. जैसे बहुत स्टूडेंट करते हैं ना, इसको भी इक्वल टू कर दिए फिर माइनस करके यहाँ पे भी इक्वल टू. सो व्हेनेवर वन इक्वल टू इज देयर बिफोर दैट यू हैव टू राइट इम्प्लाइज. And now you subtract it by matrix subtraction property. Now since this is a 3 by 3 matrix, you will get a polynomial of degree 3. अब निकालो इसको solve करके roots. You can reduce this elements of the matrix जो determinant का property देके, so that you
Ma'am,
get
The
yes,
first row
roots are
minus
0, 7, minus 3.
roots are no. You check the root again.
One is plus 3.
What?
When the first
अच्छा
row
यहाँ पे -2
minus
एक
two,
miss
minus
हो गया. हाँ, yeah, I have missed -2 away. Minus is here. Minus lambda.
मैंने वो आपको पेपर भेजे थे ना, उसको किया हो ना, उसमें से उसमें चूज़ करना होगा. हाँ. हाँ, ठीक है. नहीं कर सकते. हाँ, कर.
Minus 3 and 3
-3.
and plus 3 also.
No, you check again.
-3 and 5.
Yes, -3 and 5. अगर -3 आ रहा है ना, तो एक सिर्फ -3 and 5 don't write, because although it is repeating, since degree is 3, you have to show all the 3 roots. ठीक है, जो repeat हो रहा है उसको भी लिखना है. So these are the eigenvalues. Therefore, eigenvalues, we can write it in short. Eigenvalues are -3, and 5. Now to each eigenvalue, we have to find the eigenvectors. So to get the eigenvectors, we consider the equation. We consider Ax is equal to lambda x. That is A minus lambda I into x is equal to 0. Now you know A, you know lambda. एक एक करके lambda ले लो. So lambda is -3 repeated है, तो इसमें एक ही का ले लेना. So when lambda is -3 and I is given, you get a system of equation. Now you solve that equation. By row transformation you can solve, or you can do the normal addition subtraction also. Where यहाँ पे you can take where x is the vector x1, x2, x3. Because they are 3 by 3 matrix, so matrix multiplication will be possible only when the order is same. So you will get A -2, lambda is -3, so +3. तो वैसे करके एलिमेंट बना दीजिए. हाँ, yes, you will get an infinite number, क्योंकि यहाँ पे दो ही ऑप्शन है, either you will get a zero solution or infinite, and non trivial solution मतलब infinite ही आ जाएगा. Now you get the values of those eigenvectors. So what is the matrix that you are getting after doing the subtraction?
The first and second rows are interdependent.
You will get 1, 2, -3. So you are getting this equation. A minus lambda I into x is equal to 0. Now you solve this equation. You can do elementary row transformation on this matrix. इसी पे ही करो, इस पे जरूरत नहीं है. You can take row 2 as row 2 minus 2 times row 1, or you can do the multiplication of these elements. तो 3 तो ये आएगा, फिर उसमें addition subtraction करके निकाल सकते हो. That is also a way. But इससे करने से आसान होगा. Like you can do it x1.
eigenvector 0 0 0 आ रहा.
Eigenvector 0 0 और 0. ठीक से बताओ, गलत हो रहा है कहीं पे.
मैम for many values of x like infinite solution आ रहा है.
नहीं ये अच्छा, ये रिड्यूस करने के बाद जो मैट्रिक्स बन रहा है कैसे बन रहा है? लाइक इफ यू अप्लाई दिस ट्रांसफॉर्मेशन एंड देन यू अप्लाई, सो व्हेन यू अप्लाई 2 टाइम्स ऑफ दिस, ट्राई टू मेक मैक्सिमम एलिमेंट 0, तो यहाँ पे 0 हो जाएगा. फिर रो 3 यू कैन टेक इट एज रो 3 प्लस रो 1. तो फिर क्या आएगा? फाइनली इफ यू डू द ऑपरेशन यू विल गेट 1 2 minus 3 0 0 0 0 0 0. Are you getting like this?
Yes, ma'am.
x1 x2 x3 is equal to 0. अब यहाँ से हम लोग को क्या इक्वेशन मिलेगा? You can get the value as x1 plus 2x2 minus 3x3 is equal to 0. अच्छा, अब इसको सॉल्व कर सकते हैं. Because see, there is only one equation. A number of unknowns are 3. So यहाँ से ही हम लोग को we can guess that we can get an infinite number of solution. यहाँ से भी हम लोग guess कर सकते हैं कि we can get an infinite number of solutions since the rank of this is less. So to get the solution, you can choose any value of x1 or any value of x2. Like if we take, if x1 is equal to 0, मतलब non-zero solution means one component can be 0, बाकी non-zero हो सकता है ना? मतलब नॉन जीरो सोल्यूशन का मतलब होगा कि अगर पूरा वेक्टर अगर x1 x2 x3 तीनों जीरो है तो वो जीरो सोल्यूशन हो गया और ट्रिवियल सोल्यूशन. सो नॉन जीरो मींस एटलीस्ट वन ऑफ द एलिमेंट शुड बी नॉट जीरो. सो इफ यू आर हैविंग x1 as 0, so you will have 2x2 minus 3x3 is equal to 0. That is what you get. x2 is equal to अच्छा x2 by 3 you can write is equal to x3 by 2. So if these two equations are equal, you can name it as any value t. कर सकते हैं ना? So you can
how
get
we are
x2
x1 is equals to 0?
because we have to solve this equation. हमारे पास solution की number of unknowns 3 है, a number of equation 1 है, तो हमको uniquely solve करने के लिए क्या जरूरत होता है? Basic is that number of equations should match with the number of unknowns, but we are not having that. We are having only one equation with 3 unknowns. So we can take any value of any, we can arbitrarily choose any value according to our choice. The simplest ले सकते हैं 0 ताकि calculation आसान हो. इसीलिए तो infinite solution आ रहा है ना?
Yes.
क्योंकि choice is ours, है ना? Because choice is ours. The simplest easy way is we can take x1. We can take x2 also as 0, not an issue. Or we can take s3 as 0. कोई फर्क नहीं पड़ेगा. ठीक है? So if you're taking x1 as 0,
But you can also get an infinite number of because t can be anything. So why not just
yes,
leave
t can
the
be
first
anything.
equation as it is? Because
Yes, why not?
so why not leave the first equation as it is? Like, why to have this t? Anyway,
No, actually we have to find a vector, no? We are not, the question is not to find an equation. We have to find a vector. Vector means components of this matrix. So we have to find eigenvector means the components of the matrix. We have to find the eigenvector for that eigenvalue lambda. So we are following the theory. Then we can get the eigen.
we have to represent like x1, x2, x3 in the form of some variable t.
Yes, yes, yes. So from this what we are getting? You are getting x2 as, if you want you can take t as 1 and you can represent x2 as 3. That also you can do, but I think this is better. So if you take this as 3t and x3 is equal to 2t. So what are the eigenvectors that you are getting? For lambda is equal to -3, you are having the eigenvector x as 0, 3t and 2t for any t. You can take t as, you cannot take t as 0. अगर 0 ले गए तो फिर ये 0 solution आ जाएगा. ठीक है? It should be a non-zero solution for any t not equal to 0.
And when we have to find eigenvectors for all the eigenvalues, like we have
Yes,
to
for
also
all the
lambda is equal
eigenvalues,
to
you have
5.
to find the eigenvector which should be not equal to 0.
Like we have to
So
find
this
for
is one
lambda
eigen.
equals to 5 also.
Yes. So this is one eigenvector. If you take x2 as 2, that is also an eigenvector. x2 as 0. If you take x2 as 0, then you will get, the equation will change. When x2 is 0, you will have x1 by 3 is equal to x3 by 1. So you will get x1 is equal to 3t and x3 is equal to t. So in this case, the value will change. So you will have 3t, 0t. So this is also one form of eigenvector. If you take this as 0, so that is also another form of eigenvector. Now for the value lambda equal to 5.
2, -1 and -2.
What others are getting? Okay.
Calculating.
No, ma'am. Actually, vector for lambda is equal to 5 is 1, -1, and -1.
What others are getting? 1. This you said, no? What others are getting?
-1, -2, and 1.
Okay, finally, you tell me the matrix that you are getting, then it will be easy. When you put the value of lambda, then what is the matrix? When lambda is equal to 5. So determinant, so A minus lambda I.
-7, 2, -3.
-7, 2, -3.
2,
I think 2,
-6.
-4, -6.
-1, -2, -5.
-1, -2, -5. X1, X2, X3. So you can make this element if you want, you can make 0 or you can make this as 0. So you have done those operations. So finally, after doing operation, what you are getting the matrix? Like you can make some element 0, like you can make this as 0 by taking subtraction of 7 times of this. Or you can make this also 0 by taking 1 by 7 times of this. So after doing the operation, what you are getting the reduced matrix? Are you able to understand? समझ में आ रहा है ना? हम जो बोल रहे हैं. Like you can do row 3 as row 3 minus अच्छा 1/7 करने से फिर वो फ्रैक्शन वाला कैलकुलेशन इज डिफिकल्ट, सो इट इज बेटर दैट यू keep it in a non-fraction term. Rho 1 will be equal to rho 1 minus 7 times rho 3, because if you take this, then this becomes fraction, and you can take rho 2 as rho 2 plus 2 times rho 3.
Ma'am, the solution is coming x3 is equal to minus x1 is equal to minus x2 by 2.
Okay, you tell me what equations that you are getting after the matrix reduction. What equation you are getting?
x1 is equal to minus x3.
X1 is equal to minus x3 and
x2 is equal to minus 2x3.
x2 is equal to minus 2x3. Okay, from this equation you can say that x1 by minus 1 is equal to x3 by 1 is equal to t. Isn't you can write like this also?
Yes.
Or you can equate all these terms together also. ये तीनों को एक साथ भी ले सकते हैं. x1 will be equal to minus x3 and minus x3 means is equal to x2 by 2 लिख सकते हैं इसको ऐसे. अगर इसको minus x3 यहाँ पे लेके आ जाएंगे तो minus 2 को लेके आएंगे, ये 2 को इधर लेके आएंगे.
हम combined equation होगी x3 is x1 is equal to minus x2 by 2.
हाँ, तो वही कंबाइन, तो तीनों को कंबाइन कर सकते हैं, इसको भी ऐसे कंबाइन कर सकते हैं या इसको फिर वैसे लिख सकते हैं. x2 by minus 2 is equal to x3 by 1. So if this is t, so you can get x1 is equal to minus t. So for any value of t you will get. अगर t का value 1 है तो ये हो जाएगा मेरा 1 and x3 will be equal to t. ठीक है, when t is 1 then this becomes minus 1, this becomes 1. So when this becomes 1, x3 becomes 1, so x2 becomes minus 2. So that way, अच्छा इसको अगर नहीं ये करके that way also you can do. You are getting this as t. Therefore, x2 is equal to minus 2t. So what we are getting finally? We are getting this as minus t, t and minus 2t. So for any value of t, you will get the value.
Ma'am, if we are facing difficulty in doing row operations in some questions, can we do by making 3 equations to find the value of x1, x2, x3 respectively?
Yeah, that way also you can do. I told you that way also you can do. Like you can convert this into equation minus 7x1
And multiply
plus
the matrix.
2x2. That way also you can do.
Ma'am, x2 and x3 will be reversed. Like it is minus 2t and t.
x2. This is wrong. I have written wrong, you're saying?
I'm in the order, ma'am. This x2 will be minus 2t and x3 will be t.
Okay, x2 is equal to. Oh, this is x3, no? No, it is fine. x3 is t. I'm putting this. This equation is correct.
And the final which you have written in the in the matrix.
Achha, final t. Okay, yes. I got x1 is equal to minus t. Yes. This is 2t, minus 2t, and this is t. Yes, right. So if you take minus 1, t as minus 1, then this becomes 1, 2, and minus 1. So with the different values of t, you get different this. Now let us come to some properties of eigenvalues. These properties will be used to solve MCQ type question, shortcut method. Like if you have a matrix, this is the matrix, and A transpose is the matrix. Transpose of this, and this matrix A has eigenvalue lambda. So what is the eigenvalue of this A transpose? So eigenvalues of this matrix A and eigenvalue of this matrix, eigenvalue of this is lambda. Then this also has the same eigenvalue. These are also given in the book which I have uploaded. So if eigenvalue of the matrix A is lambda, and then the eigenvalue of the transpose is also lambda. Why? Because we know that if we are getting any matrix, we are converting it into a polynomial. So the polynomial representation will not change. Like if you have a matrix A11, A12, A13, A14. So if you take the transpose A11, A13, A12, A14. So when you are getting the eigenvalues, so you get some polynomial like this square minus some term into this plus some constant is equal to 0. Or here also you will get the same term. So when you solve it, because you are just interchanging the element, so the answer will be the same. Eigenvalues will be the same. क्या समझ में आया? यहाँ पे सिर्फ हम लोग एलिमेंट्स को इधर उधर कर रहे हैं, लेकिन सोल्यूशन तो वही आएगा. So eigenvalues of this matrix A and eigenvalues of the matrix A transpose is the same. Now there is another. This is the first property. Second property. Sum of eigenvalues of matrix is equal to sum of principal diagonal. प्रिंसिपल डायगोनल या मेन डायगोनल. मेन डायगोनल जो होता है इसको बोलते हैं. यहाँ पे कोई एलिमेंट है, दिस इज द फर्स्ट एलिमेंट, एलिमेंट इज हियर, एलिमेंट्स आर हियर. So the elements that are here, that is called the principal diagonal. So if you add the elements of those principal diagonal, that will give the sum of the eigenvalues. अब ये कैसे हो रहा है? Like if I take the simple example, if we take this example itself. So when you like if I take the example A11, A12, 1, A22. So to get the eigenvalue, what we do? This is the matrix A. For eigenvalue, we take determinant of this A11 minus lambda, A minus lambda I. So A12, A21, A22 minus lambda. This will be equal to 0. Now when we break this equation, you will get the equation as this form, lambda square minus lambda into A11 plus A22 plus A12 into A22. You will get like this. A12, A21. This into this minus this. You can break and you can see if I have make a mistake. So you will get something like this. Now if you know that if lambda is the eigenvalue, तो अगर जैसे कोई हम बोलते हैं कि कोई एक इक्वेशन दिया हुआ है, सपोज x square plus 2x plus 3 is equal to 0. अगर हम बोलते हैं x is the solution, suppose a and b इसका solution है, तो हम लोग कैसे लिख सकते हैं? That will be the factor of this, so we can write it as x minus a to x minus b is equal to 0. लिखते हैं ना?
Yes, ma'am.
तो यहाँ पे भी वही, so we are getting this is the reduced of this. So in other way, when we say that if lambda is the eigenvalue, that means it is the root of the polynomial. क्योंकि ये भी तो polynomial आ रहा है, हम लोग जो कर रहे थे तभी भी polynomial. So if it is the root of the polynomial, so you can write it as if lambda 1 and lambda 2 are the eigenvalues, so you can write it as this minus lambda into this minus lambda 2 is equal to 0. अब इसको break करो, break करके उसके साथ comparison करना. So this is one equation which you are getting here. So if you break this, so you will get lambda square minus lambda into lambda 1 plus lambda 2 plus lambda 1 lambda 2 is equal to 0. So see, when you compare this, so sum of the eigenvalues you are getting as this. Match kar raha na? So this is nothing but sum of the diagonal elements. So that is the theory, that the sum of the eigenvalue will be equal to the sum of the diagonal elements of the matrix. So you can cross check also. जैसे कोई eigenvalue निकल गया, उसका देख लेना कि value match कर रहा है कि नहीं. If there is a silly mistake, यानी तो कभी-कभी objective में दे देता है. Yes, like sometimes you get in the objective, like you get a order of the matrix एक दे दिया, उसमें बताया कि if lambda 1 is equal to some value, suppose 3 is the eigenvalue, then find the other eigenvalues. तो अब पूरा सॉल्व करके डिटरमिनेंट निकाल के आइगन वैल्यू निकालने में थोड़ा मुश्किल होगा, तो ये वाला थ्योरी अप्लाई करने से जल्दी निकल जाएगा एमसीक्यू में.
Ma'am, in the previous question, like we can compare from the previous question, ma'am. Like we were finding the eigenvalues and the sum of diagonal matrix was coming 1, but the sum of eigenvalues is coming 5. So that's not the example.
अच्छा, previous one there is, okay, let me just check.
The sum is coming -1 in both cases.
So here you are getting sum as -1. And when you are adding the eigenvalues, what you are getting? That is also -1. See, -3, -3, 5. -1 you are getting.
Yes, ma'am. Okay.
Okay.
Sorry, ma'am.
So that way you can cross check. Actually, this is actually helpful. Proof is not needed. I'm just explaining you, but these proofs are not needed. So this is one property. And the same thing will hold. I have taken a simple matrix to explain you. This same thing will hold for any order of the matrix. For 3x3 matrix also, you will see, you will have the same thing. Now, product of the eigenvalue is the determinant. So determinant, when we are taking the matrix, determinant of the matrix. So like if you have the matrix like this, A1 1 minus lambda, so if you take the determinant of this matrix, so what you will get? You will get something lambda square minus lambda into A1 1 plus A22 plus lambda A12 A21.
A11 A22 minus A12 A21.
What? This is wrong.
लास्ट वाला टर्म मैम दूसरा होगा.
हाँ A21 और A11, हाँ ये वाला जाएगा A21 A1 नहीं ठीक तो है. अच्छा ठीक है, और इससे कोई मैटर नहीं कर रहा है, यहाँ पे हम लोग जो भी है. So if you have this sort of thing, so determinant, so you will get something like this. Again, you will see that if lambda is the eigenvalue of this matrix, so determinant form, when you are breaking, you are actually reaching to some polynomial. Okay, when you are reaching to some polynomial, if you take the roots of this equation, जैसे हम यहाँ पे बता रहे थे, you can write it in factor form. So here also you can write it in factor form, lambda minus lambda 1 into lambda minus lambda 2. Isn't it? So ये जो determinant आ रहा है, that determinant is coming like this. So you can factorize this determinant in this form. Now if you take the value of lambda as 0, अगर lambda का value हम 0 दे देते हैं, तो यहाँ पे क्या आ रहा है? जैसे lambda का value 0 दे दिए, तो that becomes the original determinant. क्या बन रहा है original determinant? So
Yes,
that
ma'am,
will
yes.
be equal to lambda 1 and lambda 2. That means lambda 1 and lambda 2 are the eigenvalues. The product of the eigenvalue will be equal to the determinant of the matrix. So this is actually another property. The third property is product of eigenvalue of A is equal to determinant of A. तो ये कैसे आ रहा है, समझ में आ रहा है? प्रूफ की जरूरत नहीं, जस्ट आई एम एक्सप्लेनिंग, जरूरत नहीं है. So this property you can remember. तो ये इस तरह से आ रहा है. If you take the determinant, you can when you get some polynomial, to get the root of this polynomial, you can expand it. It's a factor form. When you take lambda as 0, then this becomes the original determinant, and that is left with lambda 1 and lambda 2. And there is another property. So you can note down this property. These are as well given in the book also, but if you note down, you can remember. If lambda is eigenvalue of non-singular matrix, then 1 by lambda is eigenvalue of A inverse. यहाँ पे A non-singular क्यों आ रहा है? Non-singular means non-zero matrix. हाँ, determinant should be not equal to 0. The matrix को हम लोग non-singular तभी exist करेगा जब हमारा inverse होगा, ताकि ये हमारा 1 by lambda हमारा exist करेगा. ठीक है, इसका proof बता सकते हैं, लेकिन अभी फिलहाल छोड़ दे रहे हैं. It is not necessary. Like इसी equation से आ रहा है. Like if you have the lambda is the eigenvalue, then we can construct the equation as ax is equal to lambda x. ठीक है, इसी में अगर हम A इनवर्स ले लेंगे, बिकॉज द मैट्रिक्स इज नॉट इन नॉन सिंगुलर, सो यू कैन टेक द इनवर्स फ्रॉम दैट, दैट इज आल्सो अ प्रॉपर्टी. सो इफ यू टेक द A इनवर्स, you get AX is equal to A inverse lambda x. So this A into A inverse will become identity matrix, ठीक है, and that identity matrix into X becomes X. So that X will become so this lambda is a scalar. So you can bring that scalar outside. So that will become lambda into A inverse X. Okay, so from here also you can get A inverse X will be equal to X by lambda. तो अब क्या हो रहा है? This is the inverse of the matrix. अब इससे मैच कराओ. So if lambda is the eigenvalue of the matrix, then we can write AX is equal to lambda x. अब क्या हो रहा है? We are writing 1 by lambda into x. That means 1 by lambda. See, lambda is the eigenvalue of A. So अब क्या होगा? 1 by lambda is the eigenvalue of A inverse. आया ना? So if lambda is the eigenvalue of non-singular exists only because we are taking the inverse both sides. अगर inverse non-singular नहीं होगा तो inverse नहीं exist करेगा. So if lambda is the eigenvalue of the matrix, then 1 by lambda is also the eigenvalue of A inverse. So this is actually the property. Now again there is another property, property 5. If lambda is eigenvalue of orthogonal matrix, then 1 by lambda is also its eigenvalue. अगर कोई मैट्रिक्स ऑर्थोगोनल का मतलब क्या है?
A into A
A into A
transpose is I.
transpose equals to I.
Yes, A into A inverse is equal to I. तो ये भी वही सेम प्रीवियस प्रॉपर्टी से ही प्रूव हो जाएगा, ठीक है? तो प्रूफ पे हम नहीं जा रहे हैं. So this is the thing. And again there is another property, if lambda 1, lambda 2, lambda n are eigenvalues of A. A is a matrix, okay? Bracket में matrix से लीजिए. So if this is the eigenvalue of matrix A, then lambda 1 to the power m, lambda 2 to the power m, lambda n to the power m is eigenvalue of matrix A to the power m, where m is positive integer. ठीक है, तो ये वाला भी टेक्निक हमें यूज होगा शॉर्टकट में. जैसे अगर हमारा कोई आइगन वैल्यू एक मैट्रिक्स का दे दिया, अगर हम बोलेंगे कि a टू द पावर 3 का मैट्रिक्स का आइगन वैल्यू निकालो, तो उतना मल्टीप्लाई करके मैट्रिक्स को मल्टीप्लाई करोगे, फिर उसको डिटरमिनेंट ऑफ a माइनस लैम्डा इक्वल टू सॉल्व करोगे, तो वेस्टेज ऑफ टाइम है. तो ये वाला प्रॉपर्टी यूज कर लेना, ठीक है, सो दैट यू कैन गेट द आइगन वैल्यू. ये भी उसी कॉन्सेप्ट से आ रहा है, द कैरेक्टरिस्टिक इक्वेशन कॉन्सेप्ट से, ax इज इक्वल टू लैम्डा x के प्रॉपर्टी से. Like if lambda is the eigenvalue of the matrix A, then we can write Ax is equal to lambda x. Now if you take the multiplication of A from both sides, so you have A into Ax, lambda x. So you have A square x is equal to lambda square x. So यहाँ से क्या मिल रहा है? So lambda square is the eigenvalue. इससे मैच कराओ. If lambda is the eigenvalue of the matrix A, so Ax is equal to lambda x. अब यहाँ पे lambda square आ गया. So lambda square is the eigenvalue of A square. ऐसे प्रोसीड करने जाएंगे तो again A cube is the eigenvalue of A. Lambda cube is the eigenvalue of A cube. So likewise, as we proceed, then we will get lambda 1 to the pi m, lambda 2. So this is the eigenvalue of the matrix A to the pi m. ठीक है? Provided m should be a positive integer. अच्छा, अब से दूसरा वाला प्रॉपर्टी चलते हैं.
मैम टाइम ओवर हो गया, कैन वी?
अच्छा हाँ, ठीक है, ओके.
थैंक
So
यू.
we shall meet. Okay, so just go through this. These are all already given in the book. We will continue in the next class. Okay.
Thank you, ma'am.
थैंक यू भाई. सर गई क्या? भाई प्रवीण तेरा बड़ा ही हो गया, ये क्या इसका मैथ्स का ये किया कोई ट्यूटोरियल? मैंने किया क्या जो मेरा